All right, so welcome to section 3. So far, we have looked at the Citrix Bleed 2 vulnerability from a technical lens, talking about how uninitialized variables and manual memory handling in C can lead to information leaks. Now, in this section, we are going to simplify the entire concept using a layman friendly analogy. So we will use the idea of a meeting room to help visualize what variables in memory buffers, memory spaces really are, and how improper cleanup or lack of initialization can lead to unexpected data exposure. And toward the end of this section, we will also take a moment to reflect on something important, that is, why do developers sometimes skip initialization? Are they stupid or is it some deliberate act? So this section will give you a clearer, more intuitive understanding of the vulnerability and also a balanced view of the real world decisions developers have to make while developing engines like NetScaler packet processing. All right, then let's dive into this section. All right, then let's break this concept of uninitialized stack memory down with a simple analogy, a meeting room in the office. So here I'm showing you the graphic of a meeting room in the office, and I'm also showing you what these different elements, what they represent. For example, what the meeting room represents, what this facility person standing here represents, wiping the whiteboard and all these different components that I'm showing you, what they symbolize. I've added the callouts here. So now imagine your company has a lot of meeting rooms, and when you book a meeting room, your company's facilities team, they get this room ready for you. They arrange the chairs, table, whiteboard, everything you need is allocated for your meeting. Think of this allocation like memory buffers or memory space that is being reserved in a program. Now, inside this meeting room, there is also this facility person assigned to you to help you during your meetings. And this facility person has two jobs, two simple jobs. First, they will wipe this whiteboard clean when needed. And second is they will write down any notes you give to them on this whiteboard. So, in a normal situation, this is what will happen. You will walk into the meeting room with a sheet of notes in your hand. You will pass it to this facility person. Since you have given them something to write, they first take a moment to wipe the whiteboard clean, whatever was there from the previous meeting. This is important that they wipe anything that might have been left over from the previous meeting on the whiteboard. Once the board is cleared, they will now carefully write your new notes on it. Clean slate, fresh content, everything works as expected, job done. So, this is exactly what happens when a legitimate user sends something like login and their user ID or some input along with login ID to the Citrix server. The server, or in our analogy, this facility person, they see some kind of input and then immediately overwrite the previous memory with the new content that you have given or the user has given. It's safe because whatever was there in that buffer space from before, it gets replaced now with new content. So that's how the normal situation plays out, all safe there. Now let's discuss another possibility where things can go wrong. For that, imagine there is a rogue employee within the company. This employee realizes after a few experiments that this facility person only wipes the whiteboard when new notes are handed over. So if someone walks in empty handed, this whiteboard is left untouched, still holding content, whatever was there written from the last meeting. So the rogue employee realizes this as a loophole and decides to exploit it for information disclosure. So they book the meeting room and they walk in empty handed with no notes, nothing to write. The facility person welcomes them, but then notices that there are no notes being handed over. So they don't wipe the whiteboard clean. They don't write anything new because there was nothing given to write. And the rogue employee now has full visibility of the notes left behind from the last meeting's participants, which could include confidential project updates, executive decisions, or sensitive strategy documents. This is how information disclosure happens. And once the attacker understands this pattern, They start booking more meeting rooms across the company, exploiting the same flaw to extract information again and again. And this is how Citrix Bleed 2 worked. Whenever a legitimate user provided a login value, the server cleared and reused the memory buffer safely. Similarly to, you know, say a good employee booking this meeting room, handing over notes to this facility person to write, then this facility person, since it sees there is something to write, they will wipe the whiteboard clean and overwrite it with new content. But when this rogue employee walks in, he walks in empty-handed, does not give any new notes to write, and thus this wiping off of the dash of the whiteboard does not happen, and there is information disclosure. Similar to when an attacker sent a request with an empty login parameter like login is equals to blank, the software of Citrix NetScaler didn't write anything and didn't bother clearing the memory beforehand. So whatever was left in that memory buffer from earlier sessions just got exposed in the response. And that's where the concept of initialization really matters. Initialization, from previous slides, we understood it means assigning a known clean value to the memory, like wiping the whiteboard clean before the next meeting starts. It makes sure that what you see is only what you intended to write and nothing left over is there. And uninitialized means nothing was done. The buffer, the space that was allocated was never cleaned. The software didn't touch it. So whatever garbage or sensitive information was already there in that memory, it just stayed there. Similar to our meeting room scenario with this rogue employee. When the rogue employee booked the meeting room, handed nothing to write, then the meeting room was allotted with all the resources, including the whiteboard to the rogue employee, but the contents from the whiteboard were not wiped clean because there was nothing given to write. Now, someone might highlight for right reasons that why does this process of meeting room has this flaw in it, where when the meeting room is allotted to someone, why the contents from the whiteboard are not cleaned before handing over the meeting room to someone, or why do these resources when they leave they not wipe the whiteboard clean. And similarly, in the Citrix Bleed 2 case, why didn't the Citrix NetScaler packet processing engine software not proactively wipe all the buffers, the allocated space, clean every time? We will explore those questions on the next slide in detail. That's all on this slide. See you in the next one. Now, let's take a moment to answer an important question that comes up when discussing bugs like Citrix Bleed 2. The question is, are developers stupid for leaving memory uninitialized? In my opinion, the answer is obviously not. It's rarely about developers being stupid and far more about the complex interplay of performance optimization, legacy design choices, and the inherent challenges of low-level programming. So, let's see the three main reasons here. The first one is performance optimization. So in systems handling immense network traffic like Citrix NetScaler, every CPU cycle and every memory operation counts, and initialization would cost you more CPU cycles and more CPU resources. Just like in our previous example, if we make the facility person wipe the whiteboard every time, regardless of whether the guest has anything to write, it would slow down the facility staff and waste their effort. Similarly, in programming, explicitly zeroing out or initializing every memory location upon allocation, especially for large buffers, large spaces, or frequently used variables, will introduce measurable overhead and slow down the system. Developers, particularly in low-level languages like C, C++, then they often choose to leave memory uninitialized, assuming that the next operation will immediately overwrite it with valid data. This is a calculated risk based on the expectation of normal execution flow. Imagine that if there is a variable which is going to be frequently overwritten very fast, then initializing it and then would cause you more CPU cycles. It would add time delay. And if you look at internet works on these network devices that are programmed on these low-level languages such as C, C++. Even your operating system is programmed on the low-level language. In that low-level language, the time domain is very different. Everything is happening at lightning speed. You pull up a web page, you post something, it's all very fast. The human time domain is very, very different and slow. When you wipe off something, it's slow, you can afford it, and you might think it's not a big deal. But when you travel into the time domain of these low level languages, there the time is very fast. It's ephemeral. It's lot of information is getting exchanged. It's dynamic. There, if you even a micro nanosecond delay can add delay to the operation and decrease performance, because there these network devices are handling immense amount of network traffic per second. So there, it's a trade-off between security and performance. This situation highlights, I agree, a classic trade-off. Where a security conscious approach would have helped, but realize that initializing all memory, performing robust input validation, and handling all error conditions gracefully, that reduces the risk, but at the same time can impact performance tremendously. And there you have to keep some kind of balance, some kind of performance optimized approach. So making assumptions about input, skipping redundant initialization steps, and prioritizing speed is normal. This can lead to impressive performance. And additionally, this is an example of an edge case. Security vulnerabilities like Citrix Bleed 2, they often arise from unexpected or edge cases that are not considered during the initial design and optimization phases. So we can clearly say that the problem isn't that the developers are stupid, but the problem is that it's nearly impossible for them to anticipate every conceivable malicious input and how it might interact with optimized code paths. So that's all on this slide. I will see you in the next one then. This is the end of this section. And in the next slide, we will summarize what we have discussed so far on this section. All right, that brings us to the end of this section. So in this section, we took a step back from technical details and used a real-world analogy to simplify the concept of uninitialized memory and how it leads to Citrix Bleed 2 vulnerability. And after that, then we also discussed from developers' perspective, like what developers are thinking when they are coding in the low-level languages and the network devices that work on these low-level languages. For them, you have to keep this performance optimization approach in mind, because security operates on this principle of uh, reducing functionality and decreasing performance. So it's always a trade-off between performance and security. All right, so we will move on to section 4 now, where we will cover some basics of HTTP post request, which are very essential to understand the Citrix Bleed vulnerability. So I will just, like how I gave you the basic understanding of programming concepts in section 2, in this section 4, in the first slide, I will give you a basic understanding of what HTTP post request is and what it means when such a request is malformed. All right then, see you in the next section.